Hello and welcome. We're going to get started this morning. This is being recorded and we are going to post it on YouTube, and so we'll do this full presentation. People will be able to come in and out throughout the talk. Rob, our Director of Public Programs, is going to be making some announcements, and so don't be surprised for the audience here if people come in and out throughout the live stream with our researchers from Paraguay. All right, so I am Dr. Stephanie Ogren. I'm the Vice President of Science and Education here at the Public Museum. And one of my favorite things that we get to do at the museum is share local, regional, and international research with the public. And so we have these really amazing opportunities with local research teams to talk about what's happening in the Grand River, or with regional research teams to think about fossils up in the UP or lake sturgeon throughout the Great Lakes Basin. And then today we're going to share a little bit about some international research that we are doing here. On the screen, you can see this is one of the most recent research projects that we've been involved in. So this is part of the rapids restoration. So if you're at the museum today or throughout the week, you might see trucks driving up and down the river with boulders, and they are working to put in some rapids as well as take out some of our first barrier dams, which is really exciting. This first phase of the rapids project is removing 4 low-head dams and putting in some really nice rock and riffle structure. And that structure has been designed with fish and macroinvertebrates, which are bugs in the river, as well as the public in mind. So this project has been in the design phase for the past 15 years, and it's really exciting to see it come to fruition. The team on the screen is a research team set up by Encompass Socio-Ecological Consulting Firm, as well as Grand Valley State University and the Public Museum, where we went through and helped them clear an area of fish so that they could safely install rocks as well as drive trucks around in the middle of the river. It's a really cool thing, so if you have a chance, take a look. You can go out to Gillette Bridge, see that area, and actually see some of the work in progress. Additionally, the bottom right corner of the screen, does anyone know what that animal is? Yes, you? It's some sort of fish. Does anyone else know the name of the fish? So we got it's a fish. What is it? It's a lake sturgeon. Nice job. So this is a lake sturgeon, and this is other really great research that we do in the Grand River. So right outside of the museum, you have a threatened species of fish that spawns there as well as reproduces and swims in the river. So there's a research team from the museum that works with the John Ball Zoo, as well as Grand Valley State University, the Fish and Wildlife Service, and the Michigan DNR to get a really good number of fish that we find and have some baseline data to see if this restoration project for the rapids improves the habitat and then improves the population of this fish. So that's just one example of local research that's happening. You, as the public, can help us with some of this research. If you want to volunteer, and I know we have some volunteers in the audience, we have opportunities to do what we call angler counts. It's a community science project where you could go out and help us count all the people fishing so we can see how the community is responding to these really amazing projects right outside our door. So that's local research and regional research. Today, we are so excited to share some international research with scientists from the museum that are actually in an entirely different country doing some amazing work. And to talk more about that, I will introduce our Director of Education, Erin Corin.
Thanks, Stephanie. All right, so our international research project we're talking about today focuses on paleontology. So I want to say this program is going to be the most fun and we'll learn the most if we get audience participation. We'll have an opportunity to ask our scientists questions. I might ask you some questions, so I would encourage you to participate. So to warm up, I'll say, raise your hand if you think fossils are kind of cool. Raise your hand if you've ever been to the Grand Rapids Public Museum before today. How about raise your hand if you want to learn a little more about what paleontologists do today. All right, and then also raise your hand if you might be interested in being a scientist yourself in the future. Cool group. So what I want to say is a bit of context, introduce ourselves, talk about some things that'll really help before we bring up our scientists waiting to talk with us and show us what they're doing. So fossils, which a lot are pictured here from the Grand Rapids Public Museum archives, fossils are the remains of once living plant and animals, and often the hardest parts of organisms become fossils, like bones, teeth, and shells. And paleontologists are people who often use fossils to study the environments and the life of long, long ago. They might want to know what the organisms that lived in the past looked like, what the habitats looked like here in the past, and how those things are connected to living organisms today. So importantly, our research team is really focusing on how fossils form. So there's a lot that goes into it, but for you to know, for today, it takes a really long time, and it relies on the animal being buried really soon after it dies, being buried and covered with mud or sand or other types of sediment that build up over time and put a lot of pressure on the organism, and stuff happens to turn that animal into rock. Maybe it gets filled with minerals, and then eventually paleontologists or scientists or just curious people will find it as a fossil. Does anybody have, I'm going to ask you a question for any brave audience members. Where do you think, so if an animal needs to be buried with mud or sand really soon after it dies, what type of habitat might be the best for fossils to form in? Do you have any predictions? Yeah. Okay, there's sand in the desert, maybe like a windy desert habitat. Good guess. Any other predictions? Yeah. A swampy area. Great prediction. Okay, so I have this brief video that does a great job of explaining what type of habitats are the best for fossils to form. Let's see what we can find out.
Nearly all of the fossils we find, around 99%, are from marine animals, such as shellfish and sharks. This is because they lived in the sea, where sand or mud could bury their remains quickly after they died. But dinosaurs live on land, so how do they get buried so quickly? Most dinosaur fossils we find belong to animals that were living near to a lake or a river. They died, and a short while later the area flooded, covering the remains in mud and silt.
Okay, so the majority of the fossils we find are in the ocean, but the big vertebrate animals like dinosaurs, they often lived by a lake or by a river. And so our research team has identified a really special river in Paraguay, which is a landlocked country in South America. Why we're there is we think the Pilcomayo River is a perfect environment where future fossils are forming now, because we know this river floods, and we have learned it can lay down mud and sediment up to 5 feet in just a couple days. So that's almost as tall as me. So animals that had recently died, like this caiman skeleton here, in this river environment, it would get buried very, very fast. We're excited to learn about future fossils and fossils forming on this landscape right now. This team you will meet today, like Dr. Ogren said, is a global collaboration. It is led by scientists at the University of New Mexico, and they invited the GRPM science curator, Dr. Corey Redman. We couldn't do this without the collaboration of Paraguayan colleagues at the National University in Asunción in their FACEN Natural Sciences Department. And we've brought in experts from Argentina and Nebraska to help with this work, because science is best done as a team with collaborators. Okay, 2 more things to set the scene. One, I want you to know this research is happening in a very, very remote rural area. You'll see when we bring them in. The team had to do a lot of grocery shopping and logistical preparations, and they're out here for 2 to 3 weeks, and they're camping every day because this is such a remote spot. Okay, to give you an idea so you have good questions to ask them in a moment, I want to show you what a typical day of field research looks like for this team. And we've called this team the Future Fossils team.
To get there, a typical day of field research generally starts at 6 o'clock in the morning, with waking up, eating breakfast, packing a lunch and water, and putting everything in our bag that we'll need for data collection. We work a pretty long day outside in the field, about 7 o'clock in the morning until 5 p.m. at night, collecting data. Members of our team focus on different areas. Some are doing taphonomy, meaning they're finding and documenting the condition of future fossils or bones they find on the landscape. Some are digging holes and finding vertebrate microsites, where they can study small skeletal elements, and some are doing geology research, flying drones and studying sediment of the landscape. The day usually ends about 5 p.m., where we can cook dinner, charge our devices like our GPS and our phones, upload the data we collected to keep it secure, and try to hit a relatively early bedtime so we can be ready to do it all again the next day.
All right, well, with that, I'm going to ask John in the booth to turn it over to our field team currently at a research site in Paraguay. So, Anna, over to you.
Hey everyone, great to see you. Happy to be reporting back live from the field again. So today we are at one of our 2 major sites at the land of a local rancher who is a huge part of this project. He lets us on his land and we get to do our research here. Today we're doing a lot of trying to refine previous localities or areas of bone that we found in years prior. And so I'll actually get to show you someone who's working on that right now. And we will head right over here and say hi to Ian.
Hello, my name's Ian Hutchinson. I'm a student at the University of New Mexico, and I also work at the New Mexico Natural History Museum. And yeah, I am currently redescribing a site of bones that we found last year that has significantly changed since the last year. And I think this is either a goat or a cow of some sort. But this is just one bone of the skeleton. This is a scapula. But what goes into it is just writing down what information, what we have on the bones, right? Like what elements of the skeleton we're finding and what marks are on the bones that might indicate difference in changing over the year. And yeah.
Nice. Thank you, Ian. So as you guys can see, and can probably tell from our not so great internet connection, we're in a super remote area like Aaron said. We rely on a little portable Wi-Fi device. So sorry in advance if we keep cutting out, but it lets us find really cool stuff and learn lots of interesting things about it. So I'm going to take you over to someone over here who has something fun for us.
Hi, I'm Dr. Ash Paust from the University of Nebraska State Museum, and I'm out here because I need to understand where my fossils that I work on back at the museum come from. My focus is mostly on marine mammals, really early mammals, and even dinosaurs. But if we want to work on dinosaurs, I think we have to understand how they become fossils in the first place. And as we've already been introduced, that's one of the main goals of this set of research. So let me show you something kind of interesting. The same animal that you just saw that Ian is working on has left some of its remains this far away, which is cool. So I'll show you 2 pieces really quick. This one is a bone called the humerus. This is of a, as Ian suggested, it's actually a juvenile cow. It's a small animal. This upper arm bone here is lacking some of the bone that would be here. And that's not because it's been chewed off or weathered away. It's because it actually wasn't fused all the way on, which happens in young mammals. In order to grow our bones more effectively, we actually don't fully ossify or turn into bone the ends of each of our bones until we get a little bit older. And so this animal must have been pretty young, definitely under 2 years old. There's another piece that's kind of interesting, just to show you how difficult it is sometimes to find these things in the field. But if I move this brush out of the way, there's a really important bone here called the astragalus. And the astragalus is one of the more readily identifiable bones that helps us determine what animal we're finding. And that's the ankle bone of a cow, which is very distinctive.
Nice. Thank you, Ash. So as you can see, we do a lot of wandering around, trying to look for really tiny things in all of this brush. But we actually work with some even tinier stuff. Aaron gave you a little bit of an intro to Corey Redmond, who works at Grand Rapids Public Museum, deals with the teeniest, tiniest bones. So you think the bones of fish, of super small snakes, or lizards. And so we're actually going to go over to his station and show you what that looks like. Hello, Corey.
Hello, Grand Rapids. Welcome to Paraguay, at least virtually. As Anna said, I'm Dr. Corey Redmond. I'm the science curator at the Grand Rapids Public Museum, and I was invited on this project by Dr. Jason Moore because my specialty is what we call microvertebrates. So I spent most of my career studying the really tiny bones. So think the bones that are produced from a mouse, small lizards, frogs, tiny snakes. They're very common in the fossil record, but until this project, we've never found any in the modern. But I've been fortunate enough to find 1 or 2 every year I've been out here. And usually the way we go about doing that is we dig holes. Because Paraguay doesn't have a lot of topography, we kind of create our own, and we're looking for changes in the sediment, in the soil profile, and looking for thin lenses or horizons that have concentration of really tiny bone. So this is a hole that I dug here in this field area. It's not actually super exciting, which is sometimes the way science goes. You can see that my kind of putty knife marks the existing kind of soil surface, and then it's just kind of the same all the way down. So we were digging, we were kind of carefully looking for any lenses or horizons that produce a whole bunch of bone. Unfortunately, we didn't find any, but I'm kind of going back through some of our big chunks and just breaking it up more. Because the bone is so small, we're looking at bone anywhere between less than ½ centimeter to maybe 5 centimeters. So pretty tiny. But yeah, that's usually what I do, digging holes and looking for tiny bone.
Anna, can we ask Corey before you move on, how long did it take him to dig that hole?
It didn't take me that long, maybe, I don't know, 45 minutes, half an hour, something like that. Some holes are easier than others. This one was a little, this one took a little longer just because it's pretty resistant. It's a finer grain, it's well compact. If you're digging something like in sand, it usually goes pretty fast. So yeah, not super long. This is actually one of my smaller holes that I've dug. I usually try to go a bit bigger, but because there was no kind of sediment soil change, you know, I could keep going down, but it's probably not worth it at this point. So I'm gonna go find another spot in this area and see if I can't find something a little different.
Awesome, thank you. Anna, I want to give you a note that the video's lagging slightly. It goes best when we just like hold the camera on one spot. The more we move it around, the more jumbling it's getting.
Cool, no worries. Okay, so we've talked about a lot of really fun stuff about how our fossils are forming, but another big area within paleontology is trying to figure out if our bones have moved a lot. Because if you have a bone on the land surface and you get a giant flood, sometimes that can move them quite a long distance. So one of the groups we have here is actually helping us kind of figure out what to expect where and how things have moved. I'll pass you guys over to our isotope crew.
Hi. My name is Remy Olivola. I am a Earth and Planetary Science student at UNM. I'm an undergraduate going into my third year, and I'm here with Sherry Nelson.
Hi, I'm Sherry. I'm a paleoecologist at the University of New Mexico. My job is to reconstruct ecology in the fossil record. So what animals ate and what kind of habitat they lived in, what the climate was like. And to do that, we use chemical signatures in tooth enamel. But the best thing we can do is come out and get modern analogs for comparison. So that's why I'm here. We don't have to have tooth enamel. We can collect plants, we can collect water. Lots of stuff has those signatures that we need. Not just to do habitat and stuff, but like Anna said, we're hoping we can trace movement of these bones through the landscape.
Cool stuff. Thank you guys. Now, we've talked to a good portion of the crew. Obviously, we're still missing a few people. We have a really large crew this year, almost 20 people. But since we have the time, hopefully you guys have some questions that we could answer. Any questions about fieldwork as a whole, what we're doing, how to get into paleontology. We have a lot of people who have all come from different backgrounds and would love to answer your questions.
Yeah, thank you. So we'll transition here. Dr. Ogren actually has a microphone that they'll be able to hear you directly if you ask a question through the microphone. So take a moment and think. Is there anything you want to ask about fossils, paleontology, what's fun here?
We already have one question.
Have you found anything like kind of noteworthy, or have you found really anything this year?
Yeah, we find actually just earlier, me and Corey were wandering through some of this forest behind us, and we found a really cool peccary skull. A peccary is essentially, if you think of a wild boar in the States, it's Paraguay's analog or version of that. And it was really cool. It looked pretty fresh and was a rather large individual. Still had all of its teeth, and that was super cool. What about you guys? Anything you find that you found this year that you think was really fun?
So we're currently at one of two field sites that we work in Paraguay. Our second one, General Diaz, but the first field site we went to earlier this week was Pozo Hondo, and we found a couple potential microsites there out on the point bar of the active Pilcomayo River. So we collected it, we screened it, we washed it, and then it's currently drying back at camp, and we're going to take it back to the lab, and we'll actually pick it under a microscope, pull out all the little bone and separate it from all the other rock or sediment that didn't wash away. So that's pretty exciting.
I want to say briefly something noteworthy. I want to shout out about Dr. Corey Redmond. So he's an expert in microsites, and those are significant in the fossil record. It gives you a great range of a lot of variety of organisms that were existing in an area. But until his work in Paraguay, there was never a modern microsite found in a river system. As far as we know, he's the first to have found that in Paraguay in South America. The first anywhere in the world, and he's replicated his findings in the consecutive years he's gone to Paraguay. So a cool first discovery in the science world from our own science curator.
Yeah, and we have another one from Ian over here.
Yeah. So speaking of Pozo Hondo, last year, one of our other crewmates, her name is Alex, she put up several camera traps across the area that we're studying. And we've been going over the data in those camera traps the past few weeks and have found a lot of cool animals. And we're wanting to see what animals are actually in the area to get a better sense of the ecology and the organisms being represented. Because the bone record doesn't actually represent everything that we're finding in the area, right? So these camera traps have provided cool animals that we've seen, like pumas, mountain lions, giant anteaters, smaller anteaters, peccaries, skunks, foxes, hummingbirds, all sorts of really cool animals that we either haven't seen with our eyes or in the bones or anywhere else. But yeah, I'd say that's pretty cool.
Yeah.
That was a great question. I think we have another one, but while we're getting that next question ready, what I want to add to Ian's answer is a lot of what we're doing with this project is studying the present to better understand the past. So we're studying a modern landscape where bones are being preserved, and we're hoping to get patterns and insights that help us better understand the ancient environments where the dinosaurs and organisms in the fossil record, reconstructing what it was like when they were alive. So studying the present to get better information about the past. All right, we've got our next question.
I have two questions. One is simple. What are those leg guards you're wearing? Are they for snakes, brushes, briars, etc.? Number two, the fossil of it looks like an alligator. That's the skin lying there. Are you observing that over the years to see how it gets covered to become a future fossil?
Yeah, great questions. And you're totally right on that prediction. We wear snake gaiters. So they have like hard plastic in them that cover our shins and the tops of our feet, so that hopefully we don't get bitten by snakes. But they also come in handy. We have a really good example of it here with a lot of this vegetation we have here. As you can see, this one has a spike that's, just about the size of my hand. So it also helps you to not get stabbed in the shins, which isn't the most fun. But yes, that is the photo you're referring to is a caiman, which is something we see pretty often here. It's a crocodilian, I believe. Yeah. But yes, that is one that we've seen year after year. It goes from having all the skin on one year to maybe the next year having less skin and being more dried out, and then being just bone, and sometimes just being gone as we've had enough deposition or soil accumulating on the surface of the land that we can't even see them anymore.
We were able to refine the exact site where that particular caiman was, and there had been a big pulse of sediment brought in by the river system, and we weren't able to rediscover it at that site, even though some of the crew had been there when it was discovered. So we're pretty confident that that is a classic future fossil.
Yeah, great question. What else? While we're thinking of another question, I want to ask, what is your snake count up to this year? Have you encountered quite a lot of snakes where those gators are handy?
3? Is that 3? So I've seen 2. I don't usually see that very many snakes. This is the fourth year I've been on part of the project, and this year I've seen 2, and I think we've seen a third one. Mm-hmm. Most of the time, it's just like snakes in the U.S. You leave them alone, they leave you alone. It's just when you're going through some of the brush, you don't want to accidentally come on one and scare it. That's the snake gators are just an abundance of caution. Thankfully, they've never been tested out. All our snakes we've seen from a safe distance, one that we can take photos and enjoy. But yeah, so snake counts up to 3 this year, which is 3 more than our leader, Jason, Dr. Moore, wants to see. He doesn't like snakes, but the rest of us enjoy seeing all the herps we can.
Cool. Well, we've got a really curious group in here, including some that might want to go into science themselves. So can you tell us, how did you know you wanted to pursue science?
Yeah, we could probably go down the line here because we have quite a few people.
So the question was how did I want to know to get into science?
Yeah, when did you know? How did you know you wanted to be a scientist?
Sure, yeah. I mean, I've always kind of just grew up around sciencey people as a kid, and I've loved dinosaurs ever since I grew up, and I feel like that's how a lot of paleontologists are. But I think a unique thing for me.
I think you're okay.
Okay. A unique thing for me is that I am also a paleo artist, so I like to draw and do artistic things a lot of the time, especially in regards to prehistoric animals. So the reason I'm actually in paleontology right now is because I really enjoyed drawing and doing artwork for museums and institutions, and then it kind of just bled into paleontology as a whole. And so, yeah, that's how I got into it.
Hi. Yeah, I really didn't want to do science when I started college, but I took a course that was called Geology of the Rocky Mountains. And it was a geology class, but it was out camping and hiking and traveling in vans across really beautiful country. And I started understanding why, or maybe possibly how, mountains formed and rivers were where they were and what rock types were where they were. And I just loved the idea that the world had these stories embedded in it that I wasn't aware of. And I was totally hooked, started taking classes. For me, it was late. I've always loved nature and science stories, but it really wasn't until college that I got excited to science. So I think there are a lot of different pathways that you can take.
For me, I honestly have never been super into paleontology until I got into this project. Much like Ian, I grew up around people who were into science, who loved nature. So I spent a lot of time outdoors as a kid, which got me really into conservation. So similar to what you guys were just told about with the sturgeons, work on protecting habitats, protecting native species and all that. But since getting into this fieldwork, which I actually applied to via an email chain, I got a newsletter for it and I was like, sure, I'll send in an application. The worst they can say is no. And here I am now in Paraguay for the second year. So shoot your shot if you have it, because it can lead to really cool stuff like this. And now I'm going to go into conservation paleobiology. So definitely take advantage of opportunities when you can.
Yeah, so I always wanted to be a paleontologist. I'm like one of those kids that never grew out of wanting to play in the dirt, collecting rocks, collecting fossils. My mother was a wildlife biologist, so I grew up in a science household. We did a lot of hiking, camping, a lot of outdoor exploring. And that's one of my favorite things about what I get to do as a scientist is field work, is being out here in Paraguay or doing field work more locally in Michigan, like the Upper Peninsula. So yeah, I feel really lucky that I get to do this for a career, and it's just something that I've always felt really passionate about.
So when I went to college, I kind of didn't really know what I wanted to do, but like as a child, I always loved the outdoors. I always thought I was going to be like a biologist or something along those lines. And when I got to college, I just wanted to do something that would be meaningful to me and the place where I live. And I feel like I just want to do something to be active in conservation and science and research and things that will just be beneficial to society and just the planet as a whole, and also feed my inner heart. So, yeah.
I was always interested in animals and nature as a kid, and basically what we call ecology, how ecosystems work, what animals eat, where do they live. And then at some point in school, I discovered deep time, geologic time, evolution, and that led me to paleontology. Back in the day, traditional paleontology was a lot of who's related to whom, what did the bones look like, how did the animal move, that sort of stuff. But I was really interested in ecology, so habitat and diet. And when I figured out the ways to wed the two, I found my niche. And like Corey, I just love field work, and this is how we get out here.
Awesome. Great answers. We definitely have time for a couple more audience questions. Awesome. We have another one.
I think you mentioned this is your fourth year there. How many more years do you expect to do field work? And also kind of how do you know you've collected enough data to be done with your field work?
Yeah, that's a great question. So when we originally developed this project as a group, it was always going to be a long-term project. And by long-term, we wanted it, 5 to 10 years minimum. So, but that's entirely dependent on funding. Funding is usually the big factor, the big limiting factor. And we've just been really lucky with, support from Grand Rapids Public Museum, from various organizations and institutions associated with the University of New Mexico, and then the last couple of years have been funded by the David P. Jones grant. So it usually comes down to funding. We're hoping to come back next year and keep going, get a 10-year time period to really get a large data set over a long time period to try to better model so we better understand where we find fossils, in the rock record and why they are in the preservation state that they're in. You know, is it going to be longer? Potentially, but that's, you know, kind of shooting for that to begin with.
Cool. Great questions so far. Anything else? I'll stall with another question that I'm curious about, and I think people here would be as well. What can you tell us a couple answers, like what's the most fun parts and what's the least fun parts of your field work in Paraguay?
Cool. Can I go first? Okay, most fun part is getting to see all the different wildlife and different ecosystems. They're so unique to this country. Least fun part, we have to change a lot of tires. We've only changed one tire this year, right?
Don't say anything.
Yeah.
You're gonna jinx us.
Oh, sorry. So we've been really lucky. We've only changed one tire this year. Last year, I think we were at 5. Last or more.
At least.
So I mean, we have a big field crew. There's 19 of us. We have 5 vehicles. They're all like 4-wheel drive, off-road pickups. But you know what? You end up changing a lot of tires, and then going and finding new tires, which is usually the limiting factor in this part of the world.
Yeah, I think my answer is similar to Corey's. I really like birds, and so being in South America, you get to see a whole different like group of birds compared to in the States, and so that's always really fun. And also, this kind of has both good and bad in it, but being in these really remote places, you get to see some untouched nature, some not quite untouched when you're on different parts of ranch land. But it allows you to see all these wild animals, but then you have to live in the untouched areas for a while. And using the bathroom outdoors isn't the most glamorous. Sleeping in a tent for a couple weeks isn't the most glamorous. You're a little stinky, but you all go nose blind to it relatively quick, so it ends up being fine. But the wildlife makes up for it, in my opinion.
You guys are all looking great. We don't know how you smell, but you look great.
No smell-o-vision yet.
So I'll add another little thing that I really love. The wildlife and the plant life are incredible. But for me, the chance to be with a group of scientists like this and then think about and see in person these sedimentary environments, these places where future rocks are being created, is a real treat. There's so much about that process that we don't understand because it takes place over such an incredibly long period of time that it's very difficult to even think about it. This is one of the few places where you can go and see those geomorphological processes, those processes that shape the earth, and have discussions about what does this say about other rocks that we might see and other fossils we might be looking for. As far as things that I don't like, the thorns that you saw earlier, they start to get on your nerves when you're trying to take photographs of a bone or walk through the woods. So do a lot of bushwhacking. It's a little frustrating.
For me,
Yeah, you're good.
I think I have to like just agree with everyone. That part is the nature and like just the environments as well. You don't get to see environments like this anywhere. Like these thorns, they hurt a lot, but like it's cool seeing them. And of course, like I want to see a jaguar, so like they're out here. Can't wait to see it again. Worst part though, at least this is just like a recent thing, but soggy shoes. And like getting a lot of swamp water in your boots, in your legs, on your hands, and it's kind of gross and stinky. Yeah, that's the worst part.
So one of the challenges of field work that you just have to adapt to is the weather. You never know what the weather is going to be. We come to Paraguay this time of year because this is in the middle of their winter. This is supposed to be their driest time of year, but it changes from one year to the next. Our first couple of days in the field were really, really hot. It hit 90, 99. And then it cooled off, which was great. And then since we've been in General Diaz, it's been kind of wet. It's been yesterday, it was very misty for most of the day. So it wasn't actively raining on us, but because we're going through all the brush, you have a lot of heavy dew on everything. So everybody came back with wet feet yesterday.
Yeah, I mean, I'm gonna agree with everybody on like for the worst part. I'm gonna start off with the worst first. Just yeah, conditions sometimes. But honestly, like at the end of the day, you kind of have to embrace it.
Mic drop. Um, I think maybe if I had to guess, that was their battery pack on their internet just dying out or their phone dying out. So we have an abrupt ending, but it's right on schedule of when we were planning to wrap up anyway. Thank you so much for your questions, for attending this event today. It's a really cool opportunity to, while we're engaging in this type of global research, that we're able to bring it back to our community and share some inspiration and insight with learners here. If you want to continue to find out a lot more about this project, we have a webpage, grpm.org/Paraguay, where we've got kind of the hypothesis, some initial findings, methods we're using in the field, and a lot of good photos. And a couple recordings of past events and glimpses of the team in the field. We're also in the middle of a 2-week-ish social media takeover, and so there's a couple days of content left on Instagram and Facebook if you want to follow the museum and hear more from our team while they're there. And then I would just encourage you, there's tons of educational opportunities to take advantage of science topics and more at the Grand Rapids Public Museum. And I wanted to call out a few that people might not be aware of. So first, this lovely picture on the left relates to this tote I have in front of me. We have a Discovery Kit loan program where we loan out for a week at a time to homeschool groups, family groups, scout groups, schools, community groups, sets of real objects from the museum archives, and we have several sets on fossils. So if you're interested in getting your hands on some real fossils from the museum with some educational activities, that's a great opportunity. We also have a digital collections website that has a ton of great records of all of the 250,000 objects in the museum's collection. So if you're interested in fossils, deep diving a lot more into what we have and what you can learn from it, that's there. And then, of course, field trips, camps. If paleontology is a topic that interests you, there's plenty of opportunities to come and learn about it here on site, as well as our exhibits. So thank you very, very much for your attention and for coming out. And we're going to wrap up. I'll be up here if anybody in the in-person group has any more questions or wants to talk more. Thank you.